The question is, 1-butane is the same starting material we're going to start. We're going to end up making 1 gram of butane or 2 gram of butane. When I write this way, you probably don't know what it is. So if I write it down to structures, it will totally make sense more. 1-butane means the double bonds, it's between 1 and 2 carbon. That's a double bond here. It makes a 1 gram of butane. So we're adding a bromine, carbon number 1. Don't see this part yet. I know it's there already. After you find out this has to be made from that, what needs to be analyzed is what is added to double bonds. And you're going to find out bromine is added, yes, definitely. Not only the bromine is added to this carbon, hydrogen is added to the other carbon. So basically, we add an HBr. That recognizes the HBr reaction, addition to double bonds. Then the question is it a Markov legal product or the anti-Markov legal product? Because depending on what it is, you have to use a different condition, right? So that's where I told you the Markov legal products have a nucleophile sitting on the more substituting carbon. And then hydrogen or the electrophile go to the less substituting carbon. This is the double bond where I think we're adding HBr, H and bromine. Bromine sitting on the less substituted carbon. That means this is not a Markov legal product. This is an anti-Markov legal product. And then you got to search your memory to want to know anything about HBr addition and make an anti-Markov legal reactions. And then you should remember that, yes, there is one, which is adding HBr in the free radical conditions. So this should be the thought process when you're solving this question. First thing is analyze what it is. Then that recognize the reagent you're going to need, the mechanism as well. And then we got to execute it. So HBr in the peroxide, that create a bromine radical. The bromine radical is going to be added to double bonds, or double bonds going to be captured the bromine radical. But when they do it, they're going to make a radical goes to the more substituted side, right? So that's the reason less substituted carbon, which is the carbon number 1, gets the bromine, and then the more substituted carbon, carbon number 2, becomes a radical. That captures the hydrogen from HBr, then you get 1 gram of butane. So this is an anti-Markov legal products. So you recognize what it is, you find the reagents and conditions based on what it is. So this is kind of the thing that you get used to it. The second part is a 1-butane becomes a 2 gram of butane. Now the bromine goes to the carbon number 2. That is a more substituted side. So nucleophile sitting on the more substituted side, that is a Markov legal product. So to make a Markov legal product of HBr addition, simple. You just have to add HBr, nothing else. Proton is an electrophile that's going to be captured by the pi bonds. That's where the hydrogen goes to less substituted side. You get the more substituted carbon cation. That is captured by the nucleophile, which is the bromine. Then you're going to see the bromine on the carbon number 2. So you can see that depending on what you do, position of the groups united can be different. And that should be the key recognitions to solve this type of question properly.